Okay. A small shop tracked its advertising spending and sales for 5 weeks as shown below. Okay, we've been given the weeks as our x variable and the sales as our y variable. Okay, so we want to show a linear relationship between the weeks and the sales. Okay, so part A, it says what is the purpose of drawing a scatter plot? So the purpose of drawing a scatter plot, please write this down if you never remembered it, is to see the the visual relationship between the two variables. You want to see the visual relationship. Okay, so for example here, if we had to plot this on a graph where sales is on the y-axis and the weeks are on the x-axis, you're going to have a graph like this one here, this one which I drew here. Okay, an upward sloping graph. Okay, as the number of weeks are increasing, even the sales are increasing. Okay, so from this upward sloping graph we can see there is a positive relationship. Okay, meaning as one variable increases, the other variable increases. Okay, just remember, like, I believe most of you took economics here. Remember, in economics, law of supply, positive relationship between price and quantity supplied, you get an upward sloping graph like this. Okay, so the purpose of the scatter plot is to see visually the relationship between the variables. Okay, if we plotted our graph and let's say it was like this, the points were like this. Here, can we say there is a relationship? What do you think? If we plot our scatter plot like this, can anybody give it a try? Do you think there is a relationship between, let's say, variable y and x? If a scatter plot came out like this, would you say there is a relationship between the two? Colleagues, this is not the time to be quiet. This is exam. We're having exam fever. Let's start. Yes, Mr. James, would you say there is a relationship if you saw a scatter plot like this one here?
No, there's no relationship.
There's no relationship, yes. What if you see a scatter plot like this? What would you say?
Again, there's no relationship.
No, there's some kind of relationship, a negative relationship.
I thought the dots were.
No, the dots don't always have to be perfectly aligned like this. Okay, it's just that in this example the dots were perfectly aligned. Sometimes they won't be perfectly aligned, but if you look at them as we can see here in this example which I'm trying to show in this diagram here, they're not perfectly aligned, but you can see the dots are like going downward somehow. You see? So you would say, okay, there I'm seeing there's some form of negative relationship. Okay? Yes. Any questions before we go to part B, where we now find this equation? Okay. Find the regression equation. Alright, so this regression equation, once we find it, it will help us predict or forecast sales in the future. Okay, that's what its purpose will be, to help us predict sales. Alright, so in this relationship here, you can see this is the equation of a line. Y equals a plus bx. A is the intercept. When x is 0, a is the value of y. Okay, that's the intercept. When x is 0, when this x is 0, then this a, whatever value it is, it's the same value as y. Okay, that's the intercept. Okay, so in this case, if the weeks are 0, they need to tell us the cell. A will represent the cells when the weeks are 0. That's what the intercept is. Okay, but mathematically, the intercept is where the line cuts an axis. If you say the x-intercept, it cuts the x-axis. If you say the y-intercept, it cuts the y-intercept. As you can see in this diagram here, this is a y-intercept, it cuts the y-axis. Here, this is the x-intercept, it cuts the x-axis. Okay, so this y-intercept is when x is 0. Okay, the y-intercept is when x is 0, and the x-intercept is when y is 0. So if we take this information back to our question, this intercept is when the weeks are 0, since x is our number of weeks. Okay, y is the predicted cells. Okay, because as I said, with this equation you can predict the cells. B is the slope. Okay, the rate of change in y for each 1 unit change in x. So meaning if x increases by 1 unit, y is going to increase by a certain amount. If x increases by another unit, y will increase by the same amount. Okay, so if your slope is, let's say your slope is 3, so it means if, in this case, if the weeks increase by 1 unit, our cells increase by 3 units. Each time the week increases by 1 unit, the cells increase by 3 units. Okay, so let us find our values here. So basically here, to get b, which is the slope, this is the formula. Okay, and you are going to see this formula given to you in the exam. N just represents the number of data values. Okay, you just count 1, 2, 3, 4, 5. So n is equal to 5 in this case. Okay. This sigma means summation, you're adding up. Sigma xy, it means when you multiply x and y, then you total it up. Okay, so meaning you multiply this and this, this and this, this and this, this and this, this and that, and you add them up. That gives you this sigma xy. Sigma x just means you're adding up all your x values. Okay, the weeks, you add 1 plus 2 plus 3 plus 4 plus 5. Then sigma y, you're adding up your y values. Then sigma x squared, each of these x values you square them and add them. Then sigma x is the total of, when you add 1 plus 2 plus 3 plus 4 plus 5, then you square that value. So let's get these values here. Okay, sigma x, 1 plus 2 plus 3 plus 4 plus 5, you get 15. Sigma y, 20 plus 25 plus 30 plus 35 plus 40, you get 150. Sigma x squared, 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared, you get 55. Sigma xy, as I said, you multiply the x and y value. Huh? Come again, I never got you.
Your network is breaking.
Oh, don't worry, I'm recording. Okay? I'm recording. Once I'm done with this question, I repost the video, okay? I'm recording.
Okay.
Yes, and I've also sent the document in the group. So if you're using a laptop or even in your phones, just open that document. Okay? Come rain or sunshine, we are finishing these topics. Okay, colleagues? Come rain or sunshine. I hope I'm clear to the others. So sigma xy, you're just multiplying the x values multiplied by the y values. Okay? 1 times 20, 2 times 25, 3 plus 30. Okay, multiplying these 1 times 20, 2 times 25, 3 times 30, 4 times 35, 5 times 40. And then you add. Okay, after you multiply all of them, then you add. So we're getting 500 here. Any questions before we start putting the values in the formula?
I didn't hear from where you began, so it's difficult to even start.
Also, you're the one who said you couldn't hear. I was breaking.
Yes.
No, I can do a small recap.
Yeah, please do, just so that we're on the same page.
Yes, we're trying to find the equation. Okay, the regression equation. Y equals A plus BX. Okay, we're trying to show the relationship between the weeks and cells using this regression equation. Okay, A represents the intercept. It's the cells when the number of weeks are 0, and B represents the slope, the rate of change in the cells as the weeks increase by 1 unit. Are we okay with that, sir? Are you able to get me there, sir?
Yes.
So we're now calculating our slope here using this formula here. N represents the number of data values, so it is 5. We counted 1, 2, 3, 4, 5. Okay, or maybe I can say number of rows or columns. Okay, there are 5. Okay, sigma xy, weeks are x, cells are y. So it means we are multiplying each of these values. 1 times 20, 2 times 25, 3 times 30, 4 times 35, 5 times 40. We multiply each of them and then we add this sigma xy. It just means you are multiplying the values and then you add up. Are we okay with that, sir? Step by step. Yes. Sigma x here, it means these x values, you are adding them up. These x values you add 1 plus 2 plus 3 plus 4 plus 5. That is this sigma x. Okay, we got 15. Sigma y, we're adding 20 plus 25 plus 30 plus 35 plus 40. We got 150. Are we okay with that, sir? Is it Mr. Matipa? Are we okay? Any questions?
Oh, we are now at the summation of x and the summation of y.
Yes, summation of x, yes, we added them, we got 15. Summation of y, we've added them, these y values, we got 150. Okay. So, the key here is, once you can read what this formula is saying, then you are in safe hands. With statistics, that's the key. You just need to read what the formula is saying. Once you read what the formula is saying, you even know what to do in the question. Okay? Yes. Then this sigma x squared, it means these x values, we are squaring them, and we add, as you can see here. Then this last one here, this sigma x squared, remember the total of x we got was 15. So that 15, you're going to square it. Okay? Yes. Any other queries? So this is the tabulation of our slope. N is 5. Sigma xy is 500. Sigma x 15. Sigma y 150. N again 5. Sigma x squared 55. Sigma x 15, which is going to be squared. And once you do your tabulations, our slope equals 5. B equals 5, which is telling us if the weeks increase by 1 unit, the cells increase by 5 units. Okay? That's what the slope is telling us. If the weeks increase by 1 unit, let me just get some bundles first. My data is about to finish. Let me just get data. Yes, colleagues, any questions so far? Any questions? Our slope is 5, meaning, even we can see in this table, as the weeks increase by 1 unit, let me see, our cells are increasing by 5. Weeks increase by another unit, cells increase by 5. Week increases by another unit, cells increase by 5. Okay, that's what the slope is saying. Any questions before we get our intercept? Okay, for intercept, you can use either this formula or this one here. This one I say is the easiest. You can also remember it. Just get the average of y and the average of x, and you've already got your slope. Okay, so if we get the average of y, okay, have you seen y? It's total. When you add up the y values, the total is 150. There are 5 numbers, so 150 divided by 5, that is 30. That is our average y bar. X bar, the total is 15 divided by the number of data values 5. 15 divided by 5, that is 3. So X bar is 3. Okay. Once you get the averages, okay, you just put back in the formula. The average of y was 30. Our slope that we calculated was 5. X bar 3. 5 times 3, 15. 30 minus 15, 15. So what this is telling us, colleagues, is that when the weeks are 0, okay, in week 0, our sales are 15. Okay, $15, 15 kwacha, whichever. Okay, that's our slope. On week 0, the sales are 15. Any questions? If you use the other formula, you just total up y minus b times the total of x divided by n, which is 5. You will still end up with 15. Okay, if you use the other formula. So since we've got our a and our b, our intercept and our slope, we now just put them in the equation. A equals 15. B equals 5. So this is our regression equation. So this equation is going to help us determine our sales, predict our sales. Okay. Okay. Like here, have you seen? Predict the sales for week 6. So weeks are represented by x. So week 6 is the same as x equals to 6. Okay. So you use this regression equation. Where there is x, you substitute it with 6. As you can see here, 15 plus 5 times 6. 5 times 6, 30. 30 plus 15, 45. Any questions? Interpretation of the slope, as we said, the interpretation, if whenever the weeks increase by 1 unit, the sales increase by 5. That's how we interpret the slope. Okay. Next, the correlation coefficient. This is just measuring how strong this relationship is. Okay. Anything less, the closer you are to 1, the stronger the relationship. Okay. Think of it as from 0.1 to 1. Okay. Either negative or positive. If it's a positive correlation coefficient, it's because you've got a positive relationship, like in this case. If it's a negative correlation coefficient, it's because you've got a negative relationship, meaning your line is going down like that. So the closer you get to 1, the stronger the relationship. The closer you get to 0, the weaker the relationship. Okay, so if there's a, for example, if you have a correlation coefficient of maybe, let's say, 0.2, and one of 0.9. The one with the stronger relationship is this one with 0.9. Okay. So this is the formula for the correlation coefficient. N, we already have our value 5. Sigma xy, we already have our value. Sigma x, we already have. Sigma y, we already have this value. N, we still have it. Yes, there's a question? Any question? Sigma x squared, we already have that. Even this sigma x squared, we already have that value. N, we already have it. Sigma y squared, we need to square each of the y values and add them up. Okay. Then this sigma y, we already have, it was the total of y was 150. So that 150 we're squaring. So the only thing we need to calculate here is just this sigma y squared. Then we can put everything in the formula. Okay. So sigma y squared here, each of the y values we square them. And you add them up. And you get 4,750. Once you've done that, you replace in the formula. N was 5. Sigma xy, 500. Sigma x, 15. Sigma y, 150. Over the square root of n, 5. Sigma x squared, 55. Sigma x, which was squaring, 15. N is 5. Sigma y squared, 4,750. Sigma y, which is 150, we're going to square that back. Okay. So 5 times 500, 2,500. 15 times 150, 2,250. 5 times 55, 275. 15 squared, 225. 5 times 4,750, 23,750. 150 squared, 22,500. Okay. We do our tabulations here, and we find that our R equals 1, which is saying there is a perfect positive relationship. Because if R equals 1, then think of the relationship as perfect. Okay. In real life, you'll never find a perfect relationship. Okay. It's just that when I was making this example, I just wanted to illustrate this. So since R equals 1, it means there is a perfect positive relationship between the weak and the cells. Alright? Yeah. Then you've also got what you call the coefficient of determination. In simple words, that coefficient of determination is just telling you how good is your equation that you've prepared. Okay. Or how well are the weeks explaining the change in the cells. So the coefficient of determination, which is R squared, it means you just square this R here. Okay, so 1 squared, which equals 1. Okay, so what, this is also a perfect coefficient of determination. What it's telling us is that the changes in cells are completely explained by the changes in the weeks. Okay, nothing else is making the cells change. It's basically only the weeks that are making the cells change. So basically our equation is a good equation to explain this this relationship. Okay, this one here just means 100%. Okay, because this coefficient of determination is in percentage format. All right, you might get, if you get maybe a 0.9 or a 0.8, you get that as 0.8, 80%, 0.9, 90%. Okay. So here our coefficient of determination is 1, which equals 100%. Basically telling us we've got a good equation. Okay. All the changes in cells are explained by the Weeks